So we've already seen that addition and subtraction are inverse operations. You can undo addition with subtraction. You can undo subtraction with addition. You can also, multiplication and division are inverses. So in this instance, this first example here, we have y divided by 6 equals 3. If I want to solve this, currently I'm taking the value of y and dividing by 6. If I want to undo dividing by 6, what I'll do is I'll use multiplication. So I'll multiply this side by 6. But I can't just multiply one side by 6, I have to do it to both sides. So multiplying this side by 6 actually cancels out the division. I get just the y left over. Multiplying this side by 6, well, 3 times 6 is 18. Let's check this. 18 divided by 6 equals question mark 3. That's a true statement. Yeah, 18 divided by 6 equals 3. So our solution here, y equals 18. I'm confident in that. On this question, we have 3 times x equals 33. So to undo the multiplication there, I wanted to use division. Divide both the top and the bottom by 3. And, well, the 3's cancel out. We get an x here. 33 divided by 3 is 11. And so you can check this again by saying 3 times 11 question mark equals 33, and that's a true statement. 3 times 11 is equal to 33. In this next example, we have 7 equals the opposite of a over 5. So one thing to notice here is that this opposite of symbol, this, you could think of it as -1 times a over 5, although the easier thing would kind of be to just lump the negative, lump all the constant stuff here together. So we'd have 7 equals a over -5. I know that I can do this because in general when we're dealing with fractions, it kind of doesn't really matter where the negative occurs. It really matters just how many negatives you have. So if you were to have the opposite of a over 5, that's the same thing as the opposite of a in front of the fraction over 5, a over 5, equals a over -5. Those are all referring to the same thing. You can always think back to the rule of a negative divided by a positive is negative. A positive divided by negative is negative, and so on. So in any case, that's all to get this, to kind of lump these things together. So you can see we are taking a and dividing by -5. To get rid of that dividing by -5, I would want to multiply by -5. But I can't just do it to the one side of the equation, I have to do it both. So I end up with a on the right-hand side of the equation, -5 times 7, which is -35 on the left-hand side of the equation. And yeah, we could check this as well. 7 equals the opposite of -35 over 5. The two negatives cancel each other out. 35 divided by 5 is 7, so that's true. You can see that this a is -35 is the solution to this equation. So don't get in the mindset that you're always going to be multiplying or that you're always going to be adding or whatever, because the operation you're going to use depends highly on what's happening. In this example, we're doing z minus 10. Addition and subtraction are inverse operations, so that means I'd want to add 10 to both sides of this one. Again, to undo the undo the subtraction rather. So we do -2 plus 10, which is 8. We end up with z equals 8. In this example, I'm taking x times -16 and getting -8. So to get rid of multiplying by -16, I divide both sides by -16. So over here, the -16 cancels out the -16. 8 divided by -16. Well, if you say 2, be careful. The order you're dealing with the division matters. 16 divided by 8 is 2, but 8 divided by 16 is not 2. 8 divided by 16, well, you can cancel a factor of 8. We're left with the 1 up top, and we're left with the 2 down below. So 8 divided by 16 is 1/2, not 2. And you can check your work. I highly recommend you check your work, and especially when you're starting to solve these equations. I think it's really worth the time to check your work. -16 times 1/2, that's the same thing as -16 divided by 2. That is equal to 8. That does work out. So that means x equals 1/2 is a true statement. And the last one on this video, we're adding 5 to y, so that means I want to subtract 5 from both sides, giving me 21 equals y, and that would be my solution there.